Thank you so much, and thank you for the invitation and for arranging this great event. Yes, so my name is Roosi, and I am the founder and the CEO of Farmers Soil Protection Organization. And I am talking today about air sampling method for monitoring the presence of fungal spores in the air. And this activity is a pilot activity, is done with collaboration of Estonian University of Life Sciences and with the scientist Kaire Loik. And this pilot activity is funded by Horizon 2020 under the Soil Agro project. Okay, so the project is itself, the Soil Agro project is focused on soil biodiversity. But as we know that everything we do on the fields, all the inputs and all the activities, it influences soil life. And therefore, Soil Agro's goals also, among others, include the reduction of the use of external inputs in farming. That includes that includes fertilizers, pesticides, fuel, and also the development of agricultural practice guidelines and tools and recommendations. And we also, everybody know about the Green Deal goal to reduce chemical pesticides. And we also want to do it without yield loss. And the goal is to reduce chemical pesticides by 50% by the year 2030. And in the farming areas where there is not possible to totally abandon the usage of pesticides, we should aim for reducing it. And we can do it with using integrated management systems and precision farming techniques. But however, when we talk about fungicide usage, then most pathogens, it takes several weeks from the actual infection to the onset of symptoms. So thus the timing of fungicide treatment based on visually detectable symptoms is not optimal way, because infected plants, they do not show symptoms of the disease early. They show it too late, and when the damage to the plant is already done. And in Estonia, 74% of fungicides are used to control grain diseases. And the grain that we mostly grow in Estonia is wheat. So therefore, in this action, we tackle the wheat. Sorry, I can't. Okay, now I put it on my slide. So how properly timed disease control avoids unnecessary fungicide treatments. So this is how it happens, is the spore has contact with the leaf. This is the first leaf picture. Then the pathogen penetrates to the leaf, and then the pathogen reproduces inside the leaf. And this whole period, this is the latency period. There are no disease symptoms visible. And as we see with the first two contact of the spore with the leaf, and when the pathogen penetrates to the leaf, then the curative fungicide would be effective. But when the pathogen has already reproduced in large amounts and the symptoms already appear on the leaf, then the fungicides are no longer effective. And as I said earlier, the damage to the plant and the crop yield is already done. So what we do is that we did pilot testing with spore sampler machine. And we combined this spore sampler machine with the weather station, and we put it on the farmer's actual wheat field. So this pilot testing was not done in testing field, but it was actual production field. And how it works is that there is lint in the spore sampler machine that collects fungal spores from the air. And this particular machine has this 7-day period. And then someone has to collect the lint and go to the laboratory to do DNA separation and then quantitative PCR mass sequestration, which shows specific pathogen species that are in the air that can infect the particular crop. And the results that we got is that here you can see that pilot testing was done in the growing season of year 2021. The orange shows the moisture of the leaf, and the blue shows the disease spores. And here on the round, you can see that in the brown ones, it shows when the preventative control is usually done in the fields in Estonia. And in the green rounds, you can see when the spore sample showed when it should be done. So the first spraying is usually in Estonia around 20th of May. And in the year 2021, it was 2 weeks too early than actually the spores of the disease were available in the air. So what happens in these 2 weeks? This is the growth period of the plant. So when the spraying is done and the plant grows, then the fungicide dissolves and it's not effective anymore. So this 2 weeks is really critical. The missing time, it's really bad. And then you can also see that the fungicide treatment, it did not work because I show here that around the 20th of June, there were visible symptoms of the disease. So the spraying, it did not prevent the disease. And with the second spraying, when it usually happens around 21st of June, but actually the spores in the air, they were around 7 to 10 days later. So around this time should have done the spraying. So with this spore sampler, it's what we want to show is that these models that we use for spraying, they're not developed based on Estonian conditions, and these fungicides, they actually are good for preventing disease, but we need to develop models based on our regional specifics and with the weather and with considering the weather conditions. So to talk about the challenges. The challenges with technology were that there was a solar panel to give electricity to our machine, but in every region we must consider that there is sufficient battery also installed, that when there is no sun during the night or when there are long periods of cloudy days, so that the machine would work continuously. And unfortunately, the company who sold the spore sampler was not was not able to help with the selection and installation of the solar panel and the batteries. We had to figure it out of ourselves. And other thing is that the spores, the spore lints, these must be collected every week on the same day and time. And actually, this when we would put several spore samples around Estonia, it would take a lot of time. So this must be considered inside the work time. But what is good is that actually these lints from spores, we can divide them exactly within 7, like how the 7 days were with each day. And actually we can cut it in a way that we can actually see the hourly spore content. So this is not challenge, this is good, but this makes it more and more important to collect in the right time. So looking for the future. So this was pilot testing only with one spore sampler. Of course, in order to develop this Estonian-based prediction system, there should be much more. And it should be always paired with the weather station. What I found is that that is not it was not too useful to use in this particular year, because we collected the spore lints and then analyzed, and we couldn't get the data like for this moment to give information to farmer this specific like day when to spray. But actually there are, I found from the internet, there are spore sampler machines that give continuous information. I don't have testing information to give you, but this is something that I would like to try in Estonia and maybe pair it with the spore sampler, the regular spore sampler, to analyze in the laboratory to see how it works. So this would give continuous information and we could help farmers better. But this spore sampler has been working really well in other regions of the world. And I put one example up here so people can watch the video. And from my side, I thank you for attention and inviting me. And if there are any questions, I'm happy to answer.